Hello again, next session in English with another very super interesting subject. We're going to talk about ports, marine, inland, well, everything that relates to water at some point, which is very well linked to hydrogen. We have here on the table two gentlemen. We have Paul Turner from CMB. He will present himself later on. And Christophe GINESTET from NEXEYA, or should I say NEXEYA and Salt? But he will tell us about that a little bit after when doing the presentations. So the subject is ports and marines and what we can do with hydrogen here. Obviously, it's we're talking about high power systems, but not only, but well, we need to decarbonize a lot. And there is a huge pressure from the global worldwide organizations taking care of our health, and namely the Marine International Organization. Paul, I would like you to first introduce what is CMB, because maybe not everyone is aware of this very big company and old company, very much involved in many subjects. But please introduce yourself.
Okay. CMB, we're a global shipping company based actually in Antwerp, and we operate ships all around the world, bulk carriers, container ships and chemical carriers. And we're interested in how we're going to decarbonize this fleet. We have a big challenge on our hands with carbon reduction requirements for 2030 and 2050, meaning that by 2030 we need to about 50% reduction in our fleet CO2 and about 70% reduction by the time we get to 2050. And if you consider any ship we launch today is still going to be on the water in 2050. So we need to do things now. Okay, great. Christophe.
Yes, good morning everyone. So I'm Christophe GINESTET. I'm working for NEXEYA, a French SME. Specialized in electronics. As you said, since the beginning of this year now we are part of the company NSOLT, which is a German company, spin-off of Airbus Electronic and Defense, specialized in electronic for defense. But NEXEYA, us, we are really also specialists of electronics. We are working mainly in aerospace and defense, but since 4 or 5 years now, we have started to work to develop solutions around hydrogen. We are starting to develop solution for stationary, mainly storage of energy by using electrolyzer, compressor and fuel cells with hydrogen. And last year we have launched a big project with ports, especially with the ports of Sète in Occitanie, south of France. And we are going to develop a barge, a multi-service barge, but mainly the first service is provide green electricity to ships, cold ironing.
Yeah, that's one of the first challenges that we're trying to address, to tackle in the ports itself, because there is a huge societal and environmental pressure on the ports itself, before talking about the ships. But the ships, they come to shore, they emit a lot, right, when they need auxiliary electricity. So it becomes obvious to provide the electricity from the shore, but it's very expensive and complex to do that with land line to address all the ports, to all the ships coming to the port. You agree with that vision?
Yes, when we bring a ship into port, it needs to maintain all the ship's services on board. And this can take a megawatt of energy just whilst the ship is there. This is not a cruise ship, they take even more. This is just a normal ship. And to provide that power to them is very difficult through cables from the port itself. The infrastructure you need to put in for every berth is too great. So we are looking at systems of, similar to a colleague opposite, putting hydrogen on barges using hydrogen diesel generators to provide the power to allow us to do cold ironing, either, say, through a barge or through stationary container systems.
So you're talking about burning hydrogen, right?
Yeah, most of our work has been looking at how we can decarbonise our shipping And in that process, we're going in a stage-by-stage process. Big ships aren't going to be running megawatt, 15 to 30 megawatts of fuel cell. We will be operating internal combustion engines for the foreseeable future. So we're looking at how we migrate from where we are today in a progressive function to those big ships. So we're working on hydrogen diesel co-combustion whilst the infrastructure is very poor. As the infrastructure develops, we'll move on to 100% hydrogen engines, and as then we get high-grade clean hydrogen, then we want to move on to fuel cells in the port areas. But we'll still probably look at hydrogen being carried on board ships in some other method, such as ammonia or methanol.
Yeah, because you need to address very, very different needs with very different spectrum of power, right? Distance to cover, different types of operations. Can you segment that a little bit for us, the different type of operations?
Yeah, so we're looking at port-side equipment, cranes, forklifts, that sort of thing, which need quite a high power output, but relatively small. So they can run small diesel engines with compressed gas. When you're moving into inland shipping, harbour shipping, tugboats, that type of thing, high-speed ferries, and short-sea shipping, we can do that with gaseous hydrogen, either with the fuel cells or with the combustion engines. Running pure hydrogen gaseous, pure hydrogen combustion engines or dual-fuel combustion engines, say, or the 100% hydrogen with fuel cells. But once we start getting into deep-sea shipping, we need to have reliability, we need to have guaranteed service. We can't have the engine stop mid-sea. So we need to be able to make sure that those engines can operate. And we're looking at there being dual fuel being the predominant process to bring us down to 80 or 90% reduction in CO2. And that coming through from maybe methanol or ammonia to give us that option. But the vessels will still have diesel on board to make sure that that always is secure on its sail.
Okay. And NEXEYA, together with Europe Technology, you are developing the Green Harbor solution set.
Yes.
And the choice, technically speaking, is really fuel cells from day one.
Yes, definitely. Yes, we have chosen to use fuel cells, hydrogen fuel cells. We are talking about power between 1 and 2 megawatts. It's the first step of our development. We are going to work with ferry, medium ferries, or RoRo, roll-on, roll-off boats. And we are thinking that 2 megawatts will be enough for a first step. As you said, effectively, all the auxiliary power unit of the ships won't be off, of course. They are going to keep at least one APU in spare. But if we are using green hydrogen, this is also important in our project, because we are really talking about zero emission system. We are going to gain a lot of emission of CO2. Roughly, in a port, we can say that between 80 or 90% of the CO2 emitted by a ship is during the stop on the shore. And we are really convinced that it's a very good solution for the environment at this stage.
And you had a lot of discussions with many ports in Europe already?
Yes, not enough.
But
not enough for the moment, but we are really...
I've seen an announcement in the news recently with the Port Autonome de Bordeaux, for example.
Yes, last week we have signed a partnership agreement with the Port of Bordeaux. Here again, we are talking about a green solution. We are going to valorize an hydrogen co-produced by chemical industrial. We are talking about 3,000 tons per year of 95% pure hydrogen. Once again, it's a green project, and now we would like also to have more discussion with Belgian port, for example. And I'm very pleased to meet you today because I'm sure we are going to have a good discussion after this.
So I know, Paul, that you've been involved in hydrogen for a long time. That's not brand new to yourself as an individual. So, but at the size of a company like CMB. it seems to me that it's a very strong strategy. You are really going forward and not waiting for the others to show you the way or tell you how to do it. You just make your way.
Yeah, the company is owned by two brothers, and they have looked at what's going on and decided we can't afford to wait for everybody to do a little pilot project here, a pilot project there, see how it goes, do something over here. We're tired of watching this funded project start, show something, and then disappear. We need solutions, and we need to be doing it now. So we are doing it. We're getting on with the business of decarbonising at a price which people can afford. Because don't forget, we have to do this in a way which we can still make money on doing it. We're not going to do this and bankrupt ourselves in the process. So we need to look at the most cost-effective ways of removing the carbon from our industry without costing us the earth in financial terms or in environmental terms. We really do need to do this in a way which is sustainable financially as well as sustainable from an environmental point of view. And that's one of the reasons we purchased the company's REVOLVE technologies with their combustion technology to look at how we can do this using existing technology but moving it just one step and just having to look at the cost of the hydrogen storage rather than the cost as well as the hydrogen conversion process to propulsion.
Yeah, it's very surprising to remind that 2 or 3 years ago only, almost no one was talking about hydrogen for the marine and for the boats, saying, well, it's too big, we cannot make it, whatever. And now we see a very strong acceleration with lots of initiatives. But how long have you been thinking that it could be a solution? It's not the day before.
We've known that we can do hydrogen combustion now for nearly 15 years. We've been slowly developing that technology, and it is now quite mature. We're just having to scale it up for the shipping industry. And the way we're doing that is really looking at a step-by-step approach. So we're going to start off with hydrogen dual fuel. So we're using hydrogen and diesel mixes, and depending on the conditions we're running, is talking about 80-85% of the energy from hydrogen. We're just using the diesel really to do the ignition process. And as we move further in, once the infrastructure is available to us, and we're talking tons of hydrogen a day, not kilos of hydrogen. Then we can start looking at how we go to 100% hydrogen engines with zero emissions. And then eventually, when we can get really sustainable, low-cost, high-purity hydrogen, then we'll look at the fuel cell.
Yeah, but the whole supply chain is probably is going to be a big issue, because when we think about the quantity of energy that we will need to transfer to those boats, it's the ecosystems that we need to build to transport and deliver that hydrogen are going to be very a big challenge for the ports. So it comes also to the solutions that we need to bring in order to transport that hydrogen. And do you see several steps to go? And I think that NEXEYA is trying to tackle this.
Yeah. As you said, it would be an iterative process. But our idea is to try to mutualize the storage, for example. The idea is to be able to provide a container, a 20-feet container, filled with a high-pressure tank. This container can be used directly at the electrolyzer to be fulfilled. Then this container can be transported. If it's between 50 and 100 kilometers, we really think that the economical approach will be efficient. And once we are at the port, we are going to take this container and put this container directly on the barge, for example, or on a ship. For example, if we have a ship which is going to use fuel cells like a generator for the engine, and we swap the empty container with the full container, providing from a huge electrolyzer in order to have the best price for the green H2.
So to create the market, it seems to be a very pragmatic approach, rather simple, more or less. But there are challenges, we know them.
Simple things, by the way.
And how do you see that issue of, well, bunkering at the end of the day?
Okay, yeah, bunkering hydrogen is going to be one of our challenges. And one of the reasons we're starting off in smaller vessels. So we start off with the Hydroville, which gave us the first process of bunkering from tube trailers. We're now launching, building the hydro tug for Port of Antwerp, and also we're installing a hydrogen refueling station, which will do the tugboat as well as refueling vehicles on land, so 700 and 350 bar vehicles and 200 bar for the tugboat. And that tugboat will then bunker from that station, but we're also looking at ways of then taking hydrogen from that station to other parts of the port to allow bunkering to take place there. We would like to look at methods also of pulling off the hydrogen pipelines that are around various ports, such as Antwerp has got hydrogen piped around it, Rotterdam has hydrogen piped around it, and so some of the other ports, and whether we can pull hydrogen directly out of the hydrogen pipelines. This isn't fuel cell grade hydrogen, this is industrial grade hydrogen, but in the combustion engine we can operate on that level of hydrogen, and we have vast quantities of that available to us.
And do you believe that the ports themselves are really understanding the challenges that they are going to face with companies like yours really going forward very strong on this pathway?
No, I think ports don't understand what's going to hit them. They tend to be very conservative people. They just want to give a berth for the boats. We don't care what goes on around it. But the political need now is going to push them forward to actually helping us with these issues rather than hindering us with these issues. And we do need the ports to come to the party to allow us to decarbonise.
I'm a little bit more optimistic from my side. We have really very interesting discussion with Port of Set. Port of Set is a partnership of the program Green Harbor, and today also with the Port of Bordeaux. I really think that they need to face a new challenge, and especially in Bordeaux, which is a port inside the city, and they're really motivated regarding new solution, and especially with hydrogen.
Do you see other companies like yours understanding the subject and putting as much effort as you're doing? Because you seem to be a sort of leader. Huh?
Well, it's nice to be the leader. We aren't going to wait for other people, so we are going to go ahead and do it, and we hope people follow us very closely. We have to do something, and we can't just carry on in the pattern of doing one single study here or one single study there. We need to put a proper roadmap in on how we're going to deliver zero emissions to shipping, zero carbon. And that is going to take a lot of effort, and everybody has to come to the party to get on with it.
Because honestly, it's kind of crazy. There are objectives to decarbonize all the boats by the 2050, more or less, right? And you said the industrial cycle and the lifetime is, you say, 20, 25 years?
A typical ship we can launch today will still be on the water in 2050.
Yeah.
We might not own it at that point, but it will be on the water, will be plying its trade. And the 2050 targets are global targets. That means all shipping. So a lot of that shipping will need to be zero emissions if those older ships are still going to be sailing. So we have a massive challenge. Pretty much any ship we launch from 2025 needs to be zero emissions. And hopefully our first ship will be on the water in 2023 running ammonia to give us a first look at that technology.
I'm not sure the whole industry understands the challenges and the speed, the pace that you need to have to get to that point. But the example that you are showing is probably a good flag that we need to advocate. Thank you very much, Paul. Thank you very much, Christophe.
You're welcome.
I wish you an excellent day here in Hyvolution. Have a good day.
Thank you.